Welcome to this video on S2. Today we're looking at modelling with the continuous uniform distribution. Now this is just nothing new essentially, but what we're going to do here is take what is essentially real life situations, which is where this will be used, and essentially apply it. So in today's video, I'm not going to be doing anything new. I've just picked out 3 questions, and what I'm going to do is I'm going to give you a little bit of time to do one, then I'll go through it, and then I'll do the second one, and then the third one. So today, think of it as just a consolidation of what we did in the last video. So looking at this question, we can see we have a continuous random variable L, and when I go through we can see it's actually continuous uniform, because it tells me that there. And here's my interval between -4 and +4. So I can think of a quick sketch between -4 and +4. And of course then this is going to be a height of 1 over b minus a, so 1 over 4 minus -4, so 1/8. So there I have my little sketch straight away to help me out. Now from here, parts A and parts B should be quite straightforward. So if I look at part A, for example, and we'll take another copy of the sketch, and what we want to do is I want to look at less than minus 2.6. So minus 2.6 says there, less than would be this area. So what we've got is we've got a base here, the difference between these two values, and a height here of 1/8. So all I want to do now is just think, well, it's just the area of a rectangle, isn't it? So the probability of L being less than minus 2.6 is the difference between minus 2.6 and -4, and that will be 1.4, and we want to times that by the height, which is 1/8, and that will give me 0.175. Exactly. Now we want to look at part B. I'm just going to make a bit of room. So if we're looking at part B, we want less than -3. So that would be looking at -3, and we want less than that area there. And we also want greater than +3. So again, looking at +3 and greater than. So we've got these two areas. Now they're both the same size, so I can find one and double it, or I can find them both separately and add them together. Choice is up to you. But the same as before, it's a rectangle, so we've got 1 times 1/8. So I want to write out my probability, the question. So we're looking at probability L is less than -3, or L is greater than +3. So 1 times 1/8 plus 1 times 1/8. So that's going to give me 2/8 or 1/4. Again, I can write it as a decimal if you prefer. And as I said, parts A and B were very straightforward. Part C is where we expect it to be a little bit more challenging. Now, part C says we have a random sample of 20 rods. So we're going to need to know that in a moment. Find the probability that more than half of them were within 3 millimeters of the target length. So you want to think of the target length as being this 0 here, and within 3 millimeters would mean that we want plus or minus 3. So first we want to find the probability of that happening. So the probability that we have L is between plus or minus 3 is going to be this length here, which is 6, and the height 1/8. So 6 times 1/8, 6/8 or 3/4. So that's my first probability done. And I want the probability that more than half of them were within this. So I'm looking at probability of x being greater than 10, more than half, and x is a binomial, and it is n is 20, and that probability is 0.75. Now, if I'm using my calculator, I can actually do it straight from here. However, if I'm going to use the formula booklet and the tables, I'm not going to be able to do it because this probability of 0.75 is not in my tables. However, 1 minus this, 0.25, is. Now, before I go down that route, if I was going to use my calculator from this point, it would essentially be a 1 minus the probability that x is less than or equal to 10 using this distribution. And I would get 0.9861. Now, if I'm going to use the tables, I need to redefine what I'm going to do. So this time we're looking at when the success, don't know what is going on with my writing there, my spelling, success, terrible. So the success now we're looking at is outside of our 3 millimeters. So that means our probability is going to be 0.25, and the probability we're trying to find, we're going to use this as y this time, and the probability is going to be less than half. So we want that y is less than 10. So this time we're looking at finding, let's write down our distribution. So y is going to be binomial 20, probability 0.25, and we are looking at less than 10, which we know is less than or equal to 9. And now we just need to look at it from our tables. And then reading across from our 9, we can see we get 0.9861. Exactly the same answers we had up here. And there we are, done. So this is one of those questions, first couple of parts, nice easy marks. When it comes to part C, that's when it gets a little bit more challenging. Now, as with the previous question, the first parts should be quite straightforward, and then it will get a little bit harder. So here we can see we have a continuous uniform distribution between 0 and 10 minutes. Find the mean and the variance at the time Gene spends in the queue. So we know that the distribution is uniform and it's between 0 and 10 minutes. And then for A, E of x, remember for uniform ones is just A plus B over 2. So 0 plus 10 divided by 2 is 5 minutes. Nice and easy. Variance, remember this is now B minus A squared over 12. So 10 minus 0 squared over 12. So it's 100 over 12. Or 25 over 3, which is 8.3 recurring there. So up to you kind of how you you record that one. Now part B, find the probability that Jean does not have to wait more than 2 minutes. So let's just do a quick little diagram. You know I love a diagram. So we're going this time from 0 to 10. So that's going to have a height of 1/10. And we want her to wait no more than 2 minutes. So no more than 2 minutes means that we're cutting off at 2, and we want this area here. So that's nice and easy, isn't it? Probability of the waiting, should we call it W? No, we call it X. I've already called it X here. So no more than 2 minutes. So it's a length of 2, a height of 1/10. So it's 2/10 or 1/5. Or I suppose 0.2, whatever again you prefer there. Now for part C, we've got a little bit more information. So Jean visits the post office 5 times. Find the probability that she never has to wait more than 2 minutes. So this is a binomial, but because it's never has to wait more than 2 minutes, this is just going to be quite straightforward. It's going to be my 0.2, which is the probability that she doesn't have to wait more than 2 minutes, to the power 5, because it would be that times that times that times that times that, isn't it? And that would give me 0.00032. Nice and easy. But again, it's one of those types of questions that sometimes throw people up. Or if in this case it was quite straightforward because it was all 5 times. If it wasn't, then I am looking at a proper binomial part of the question. Now for part D, let's break it down. So she's got a message, she's got to return back to work, blah blah blah. She can only wait in the queue for a further 3 minutes. Given that she's already been queuing for 5 minutes, find the probability that she must leave the post office queue without being served. So let's think of our diagram. Obviously originally it went from 0 to 10. However, in this case she's already been queuing for 5 minutes. So it means that we're starting there. We can ignore that first 5 minutes. So we're starting at 5 minutes up to a maximum of 10. Okay, because that's what it's told us, given that makes it easier doing it this way. If she can queue for a further 3 minutes, that will mean the cutoff point is going to be at 8 minutes, isn't it? Okay, so that's our cutoff point. Now the question says without. So we're looking at her with leaving. So that means that's the section between 8 and 10 minutes when she would have been served. Okay, does that make sense? So in this case, this probability is going to be the length here, which is 2, over the total length, which is 5, and there we have it. Okay, so the probability where we're basically looking at it being that greater than 8 minutes, given that she's already been there 5 minutes. So I suppose we're looking at probability when x is greater than 8, given that x is greater than 5. That's essentially what we're doing there. And you can use the formula, but using the diagram is just so much easier. Okay, let's have a little look at this question. So we can see again, obviously it's a continuous uniform distribution. That's what we're looking at in this video. But you do need to think about this in an exam. And we have the interval here between 7 and 10. stick is selected at random from the box. Find the probability that the stick is shorter than 9.5 centimeters. So again, as always, I do like to draw a little diagram. We've got between 7 and 10. So that is going to have a length of 3. So a height of 1/3. We want the probability, let's actually write it down as well. Our distribution x uniform, and it is between 7 and 10. So probability that x is less than 9.5. Well, that's going to mean that I need to look at 9.5 in my diagram and less than, so we're looking at this area. So this distance here is going to be 2.5, and we want to times it by a height of 1/3, and that will give me 5/6. Obviously I can write it as decimal, but it's going to be recurring, so it is up to you, but I'm not going to bother. Now for the next bit, we want to win a bag of sweets, and a player must select 3 sticks and wins if the length of the longest stick is more than 9.5. Okay, so we only have to think about one of the sticks essentially being that 9.5 or above, and then we win. But surely there's an easier way, and there is. So if I think of losing, the only way I lose if all 3 of my sticks end up below 9.5, which is what I've got the chance of here. So if I think of losing, probability of losing would be if all 3 sticks end up being less than 9.5. And then that would mean then by definition winning would be 1 minus that. So the probability that I win is 1 minus 5/6 cubed. Okay, and that's because I'm looking at all 3 sticks being less than that 9.5, which is when I lose. 1 minus losing will equal winning. So very straightforward in my calculator, and that will give me 91/216. Again, I think I'll leave it as a fraction, and let's move on. So looking at it this time, we've got here, to win a soft toy, player must select, so it's 6 sticks this time, and wins the toy if more than 4, so we're looking at more than 4, are shorter than 7.6. So the first thing I want to do is find that probability. Find the probability of being shorter than 7.6. So probability where x is less than 7.6, well, that's going to be 0.6 times by 1/3. Oh, that's nice, 0.2. Now let's say that y be stick chosen, again, sorry, my spelling, chosen is shorter than 7.6. Okay, that means we have a binomial expansion with n is 6 and the probability is 0.2, and that is going to be in my tables as well, so that's lovely. Now for us to win, we need the probability that y is going to be greater than 4. It says more than 4, doesn't it? Which is the probability of y being greater than or equal to 5. You know, I always like to, for discrete data, make it greater than or equal to or less than or equal to. So now I can see that this is 1 minus when y is less than or equal to 4. At this point, you can go to your tables or you can go to your calculator. So we can see here our 4 is 9984, so 0.9984, and 1 minus that is 0.0016. And there we have it, nice and hopefully straightforward. Hopefully you've got some use out of this video. Coming up is going to be a couple of short videos soon on sampling and sampling distributions. And then we kick into the main one, which is going to be our hypothesis testing, which is the one that I think most students do find challenging. Okay, so if you're finding these videos useful, don't forget to like, subscribe, and maybe hit the bell icon so you're notified the next time a video drops.